Good morning.
Good morning.
Good to see you all. Be amongst such amazing people.
Duffy will do the talk and I'll just stand here.
All right.
Take the credit.
So this is a talk called Malicious Compliance Automated, and we're going to be talking about, we're kind of revisiting some things that we've talked about before. So as a way, by means of introduction, I'm Duffy Cooley. I'm Maui Lion everywhere. I'm the field CTO for iSurveillance at Cisco. My job hasn't really changed in that time, so I still am doing all the things for iSurveillance that I was doing before, still going to market the same way, still interested in moving forward with Cilium, and now with new funding from Cisco, we're actually pushing further into what's possible with Tetragon, so I'm super excited about that.
And I'm a founder of Autonomous Layer, which was called Autonomous Plane. And naming is hard, and sometimes you can't get the .com that you want, so you go with plan B, right? So that was plan B. And it actually works pretty well with containers that have layers, etc. So I'm pretty happy with that. I'm also the DockerSlim guy. I created the DockerSlim project, and we'll use that in this talk.
So this talk is heavily influenced by a talk that I and the rest of SIGCONC did in Amsterdam, and this talk will focus on what can be done to automate some of the things that we did that enabled us to fool or change what scanners can see, either intentionally or by happy accident.
Exactly, and then there's a lot more that can be done there, and that's why we're doing this talk, because I spent a few cycles to find additional ways to break vulnerability scanners, and it's always fun to break stuff.
Next slide. No, doesn't really want to go. There we go. So,
okay, so a little bit of context. We framed this talk as a journey for a developer. I'm this developer. I just finished an application with 24 hours to go. And you know this feeling, this rush, racing against the clock to meet the deadline, and then you feel like you're done, finally it works, and you're happy.
Yeah, ready to ship it.
That's where I am. And this is a node application, a server management application with a couple of endpoints. And this is the beginning of the journey we're going through.
But there's going to be trouble. Kyle has pushed his image to Quay, and this is our first scan from Claire, which is a built-in image scanner. Claire sees 3,232 vulnerabilities or issues that are fixable.
I go from high to low.
Yeah. And 158 of those are critical level vulnerabilities. Side note, not all of these are exploitable, obviously. I mean, this is one of the things about vulnerabilities, but like a ton of these things might be in there just because they came with the actual base image rather than having anything to do with the application that's being shipped. But security probably doesn't care too much about that. So what are we going to do? What are we going to do? So the security folks are also using Docker Scout to look at images amongst other tools. Docker Scout shows a very different result. Scout sees 26 criticals, 138 highs, versus 158 criticals and 1,271 highs. We can see that scanners across the board actually see a variety of different results, which is in itself kind of a weird problem, right? Like, if we're looking at the same CVE databases and those sorts of things, why don't we see some correlation between these things? Which scanner is the one that I should trust? Should I go for the one that has the most matches? Should I go for the one that has the least? I'm just trying to, like, he's just trying to get this thing shipped.
And we're getting back to where we are. It's only 24 hours, thousands of vulnerabilities. Yeah. The traditional way to fix vulnerabilities isn't going to work because it's about 3 hours to triage a single vulnerability on average, 8 hours to fix them. Multiply thousands by 8 hours. The math is naive and primitive, but the problem is there. So we need a different way.
And this talk is entitled Malicious Compliance. So what is the way we're going to do it?
What if we could remove things we don't need as a way to get started? And this is actually how I created the project, the DockerSlim project. I wanted to have production-ready containers, wanted to reduce the attack surface, I knew that it wasn't going to remove everything, but one of the main gotchas with this, even though this is the concept that many people talk about, don't put stuff you don't need in containers. In practice, you don't know what you need. You don't know what you don't need. Yeah. And yeah, it sounds good in theory. Some people do, and some people are better at finding out. But I'm lazy. I wanted to have an easy way to do it. That's why the project was created, and now it can do a lot more. It can work with more than just Docker. It can tell you a lot of interesting stuff about containers. It supports many different runtimes, building images, including remote builders like Depot, shrinking images, and then also debugging them. This is the only tool that supports all major runtimes to debug minimal container images. And you need a way to debug them because you don't have a shell. But we're not talking about debugging.
And it is an open source project. You can find it on, GitHub and explore what's happening there.
We're going to shrink the application container first. So here, this is an example, a little bit of animation where we run the slim command and we pass a few flags. And if you use the tool, you might know some of those flags, but some of those flags you probably don't know. And this is the case with one of the flags, HTTP probe full. That was a question you had. So what the heck is that flag? And honestly, I don't even know all flags. And I built the tool. So, and this is a universal problem with many tools, DevOps tools. You don't necessarily know everything about them. And that's actually the reason why I thought, why not leverage some of the new tech that's out there and build an assistant? And on the next slide, we're going to use that assistant to ask about the flag Duffy was curious about. So what is this HTTP probe full flag? Yeah, and if we look at the output, it gives you a short overview, and it gives you a few parameters there. If I don't know if you can catch it, but there's a hallucination there. It's okay if you don't spot it, but it's not perfect, and it has the usual gotchas that you normally get. Sometimes you don't get the exact answers you want, and the answer there is the type. The type, it says it's a string, but it should be a Boolean. But it got the default type right.
So what do we get from vulnerability scanners at this point? So after this run, I run the report the security gave me, and I can see that now there are only 5 vulns, and none of them are critical. Watch me fumble through the typing here for a moment. So this is just using Docker Scout. And I've already made a huge improvement just by slimming the image, right? I've made a huge improvement.
How many does Claire find?
Say again?
How many does Claire find?
Claire, at the moment, I believe still finds, Claire might be cached, but we're going to talk about it here in a second. As a reminder, here's what the old stats look like across all of the different scanners, and this is what it looks like after the change, right? So we can see OSV scan doesn't find anything. Claire will also not find anything, but we'll talk about why that is here in just a minute. But Docker Scout's down, Snick's down, Gripes down, and Trivri is way more tame than it was previously. So let's see what happened. So Docker Scout has a compare tool, which is actually super useful. If you have 2 different images and you want to compare, like get an idea of what the CVEs are and the 2 sides of things, this is a pretty good way of doing it. And what I'm doing here is I'm looking at the original image and the slimmed image, and I could still see 6 highs, but you can really see the difference between these 2 things, like size-wise, package-wise, and vulnerability-wise is greatly reduced.
Yeah, we did it, right?
I mean, if it's only 6, I probably could get like exceptions for that, but I'm not going to get exceptions for 138, 26. That's not a thing that will be happening.
It's a better place to be.
Yeah, 433 vulnerabilities removed. So in our example, the minification wipes out all the files that aren't needed to run the app and pass the test. And as a result, tools that focus primarily on the OS, to your question about Claire,
right there,
right,
unsupported,
are now blind because they don't find that metadata that says this was the operating system that this was based on is not there anymore.
So it just gave up, didn't even try.
Yeah. So what happened to that OS metadata, right? Like these are the things.
That's a good question. So one of the things Claire and OSV Scanner cares about is etc. OS release. This is where you get the distro metadata, and that's what many vulnerability scanners use as a starting point for their journey to determine what kind of vulnerabilities they need to look for. And if you look at the output, you'll have references for the tools that we used. If you look at the output of the etc. Directory and also other top-level directories, you won't find some of those files and directories, including the var directory, where Debian has a lot of the metadata about the system packages and the logs about installing stuff. So right there, we removed the basic OS information, and Claire and OSV Scanner were out, but we still have vulnerabilities. We still have vulnerabilities that we need to take care of, and we need to do more. And that's a good question. What can we do?
Yep.
And we can ask the assistant again. And here, if we switch to the next slide, here, a little bit of animation asking the assistant, how can we hide the rest of the vulnerabilities? And the assistant is set up as a rack system. If you want to know about the design, I have 3 different designs there. I've done talks about different assistant designs that tell you, that use different tools and techniques. So it's a rack system that knows everything about Docker Slim and the container image. That's why it's able to answer that question. So in addition to the flags that we've seen already, there's an additional flag that tells us we can use to hide the vulnerabilities. And if we go to the next slide, it'll zoom into the important section. It'll tell you more about this extra flag, and it'll describe what it'll use, what it'll do. So it's intentionally hiding stuff from the vulnerability scanners and not even, pretending that.
Because at this point, we want to be really compliant. We want to get all the way to
really
0.
Really compliant. So
trying to figure out how we can actually do that.
Exactly. So let's see what happens.
So let's use the command that the Mint AI recommended for us, and we'll actually do the obfuscation, and we'll see what this looks like after. So we're able to get through that process. And what do we get from the vulnerability scanners now? A lot of them are like, we're good. There's nothing to find here. Like, we haven't actually changed too much in the image at this point. I mean, this latest change with like the obfuscation piece, it actually does change some things in the underlying image, but fundamentally what we've done so far is we've removed a bunch of things. And this is one key difference, I should say, between this presentation and the presentation we gave in Amsterdam. In Amsterdam, we didn't change the base image at all. We just manipulated what was inside of it. But all of the vulnerable stuff was still inside of that image. In this image, when we did that Docker Slim image, we knocked out like 400 meg of stuff that was actually matching on those vulnerability scanners. So we made a significant change. Sorry, I was mixing my scripts up. So we removed a bunch of stuff from that image in this one. And in the second step, we also modified what's in there to clean up or to further obfuscate some of the things that the vulnerability scanners were able to find. So now, what do we see? We're completely compliant. We're ready to ship.
Perfect.
So this is another difference, right, between the minified image and the obfuscated image, right? We can see, actually what's interesting is that we grew in size a little bit. We have the same number of packages, right? We see no more vulnerabilities, and we see that right here in the bottom line is kind of an interesting state right here, because it says 102 packages changed and 11 vulnerability changes.
Right there.
Right. So what is 102 package changes? What changed about those 102?
Yeah, so that's a good question. So when I watched the original talk in Amsterdam, Malicious Compliance, I wanted to apply the techniques they talked about. And what I discovered is that with the applications I had, they didn't hide everything in my application. So I went on a mission to find additional ways to break vulnerability scanners. And this is an example where we're changing the binaries. As you can see, the sizes are different. The hashes are different, and the content is also different. At the very end of the node executable, there's a little bit of data with my initials in there. I signed them. There's more going on with Node.js and other runtimes. For example, we're also obfuscating the signatures, version signatures, so the vulnerability scanners can detect the Node.js version, so they can find the vulnerabilities associated with it. So.
Yeah, and it really highlights the two, kind of the two categories of scanners. Like some scanners actually, again, like really just go after the OS. They want to be able to find that metadata that says this was based on an Ubuntu image. They're going to go hit the CVE lists that are known about Ubuntu-based packages. They're going to find matches and they're going to tell you about them. But if you remove anything that says, oh, this is an Ubuntu image, all of those vulnerabilities are still there. They just can't find them anymore, right? And then this one, what this does is it actually takes the obfuscation another layer deeper, right? You're saying some scanners, Gripe, Sift, things like this, they will actually evaluate the binaries themselves, look at the metadata for the binaries themselves. They'll go in there and see if you have any node npm packages and those things installed and evaluate those. Not looking at the Ubuntu repository, but at the npm repository, right? A different set of data. And this defeats that because it basically makes it so that they don't match anymore. Go ahead. Actually, before you ask your question, I gotta go to Mike because we're recording. Yeah.
Hold on like this.
And some scanners do hash-based
Is it working?
lookups.
Yeah. Does it also kind of output that these are now I found 5,000 files that I didn't know about, or doesn't it does it ignore that? Doesn't kind of output to the developer that well? I didn't understand this.
Sometimes they'll just tell you that they find a bunch of files, but they can't correlate them to anything until they'll say they find a bunch of files. But
It's kind of a known unknown.
yeah.
Okay, that's good at least.
But frequently, like, as you saw in the output on the previous slide, it just will say, will throw its hands up and say, there's nothing to find here because there's no correlation.
So maybe you're about to get to this, but what I'd really want is to obfuscate the container image for attackers, but still be able to scan it myself.
Yes.
Is there
Yeah, so if
is
you
there a way
pulled
to do
this
that?
image, are you saying, can you scan them?
Yes.
Yeah, if you pulled the images that you see by name from Quay, you'd be able to scan them yourself, and you would see the same results that we're showing on the screen.
Right. What I'm saying is I want to be able to scan it non-obfuscated.
That's the very last slide.
Okay.
All right. Well, let's keep going then.
Okay.
So, second, the Node.js package, go ahead.
Yeah, so the second kind of change that we got is the application package metadata change. That's where those 102 changes came from. And what we did, we rewrote the node package metadata. And if you look at the output from Sift, you'll see that, for example, for the accepts package, we went from version 1.3.8 to version 11.3.8. And the way the vulnerability scanners work, they take the metadata from the image they scan, and they take the name and the version, they do a lookup. And obviously for this version, they're not gonna find anything. Pretty naive, pretty basic and easy to break, and that's an example of doing that just by changing the metadata. But there's more we can change.
Even more, yes.
So here, it's a little busy, but it's a journey from the original image that shows what we have, 600 packages, a whole bunch of 10,000 files, a bunch of executables, to the slim image where we have only 50 packages, 60 executables, to the version where we mutate the package metadata version, and then we can also mutate the package names. So this is one example of name mutation. You can choose a random name. The app will still work, but the scanners will fail because they won't be able to do a lookup. And you can also remove the names completely, which is the case right there. We see 0 packages. And that's because the names were removed, the packages are still there.
So in refreshing this talk from our previous presentation of this at SecurityCon in Seattle a while ago, we noticed that actually some of these scanners are doing more work than they were previously. So the state of the art has changed a bit, and it's exciting to see. But like one of the big takeaways from this particular talk is that we need to drive more change in this, right? And because this is now automated, you can take this tool and apply it to images and show them to your, show them to the people who are like writing software for actually scanning for vulnerabilities and those sorts of things and say, you gotta do better. Like if I remove just the OS metadata, it makes a huge impact on my ability to understand that there are vulnerabilities in this image, right? And I want you to do better than just look at OS metadata.
Exactly. And if you don't ask, things will not change.
Yeah.
The status quo will be there. So that's what we're asking. We're asking for change, and we want you to ask for change.
Yeah, but having this automation makes it super easy for you to prove this out.
But
Take
to
it.
answer that question,
Yeah.
is it possible to scan and get the results from those images?
Yeah.
Yes, it's possible. It's just you don't get that with the scanners that exist, and this is something that I'm actually working on to detect the vulnerabilities, the packages, even when the traditional metadata isn't there.
Be the change you want to see, I guess. Yeah, that's awesome. What other questions do we have?
I'm a little concerned at the idea that a package can exist without a name. That seems like something that the package system itself shouldn't even allow. Like, is there a valid reason to ever do that?
Great question. I mean, like, what if you wrote the package, though? That package isn't in a repository anywhere. It's still just a local package.
You should still give it a name just for your own reference and nothing else.
Right?
Instead of constantly saying stuff.
Go ahead.
I got it right. If only.
So let me make sure I got this right. You're saying until somebody updates these tools or writes a new tool, we're basically all screwed if we pull a image from Docker Hub or Quay that we don't know the author and fully 100% trust the author. There's
mean,
no way
I-
for
that
us
is
to know
something I
for
would-
sure that is a safe container.
I think one of the first times I ever saw somebody say something like that was Adrian saying, know what's happening inside of your cluster. Actually, I remember that talk. That was a good one. But I do often say that, and I would qualify that with, in this scenario, right? Like even your scanners may be lying to you if they've been minified, if they've been modified from the build image that they originally kept. I mean, even if you're just doing even if you're doing a multi-stage Docker build, like what's left in the image after that second stage? Like, how are you scanning that? How do you know that the scan results are viable? How do you it's a tricky question.
But it's a great attack vector. You build an image with a whole bunch of vulnerabilities that you exploit later on as a way to get in.
Yeah. Go ahead.
How receptive have the vendors been to fix this problem? Like, why is Ubuntu this way out of the box? It's been over a decade.
I mean, I don't have any direct information on that. Do you have anything?
I think it's about how it's perceived. It's perceived as a compliance problem where you're a developer, you're building an app, you just want to ship your app. Then you have InfoSec. They scan your application, you get a Christmas tree report. You don't necessarily like the InfoSec people, you just want things to go away. And the InfoSec people, they scan it so they can check the compliance box. But there's more to it. And it's been it's based on the status quo. That's where it's been, a compliance checkbox. People haven't been thinking about other potentials, so it's just stayed that way for decades. That's why we're asking for change, because there's more to it.
And as we said before, when we were refreshing this talk, we did notice that some of the tools like Sift are doing, Sift and Gripe are doing more work. It's kind of a little strange because they're directly looking for particular binaries by name as opposed to just trying to look for metadata in packages and those sorts of things. So there's they're starting to get better and better at it, but they would catch that thing where you did the multi-stage build and copied curl in, right? But that's a recent change. So they're starting to kind of get it. I think enough people have been telling them that this is probably not good enough.
And the antivirus tools went through a similar journey.
Oh yeah.
They're just ahead. And initially they weren't that great, very primitive, very naive, and then they had to evolve because they had to.
Probably our last question. Go ahead.
I know that we're looking at containers that are built from different operating systems and whatnot, but before I got into cloud native stuff, I was all into security.
And we would also, to isolate things, just have a single binary in the container so that the one program you wanted to run or the various limiting specific files. Is that what Mint is doing to some respect, but still leaving around operating system level?
Are you asking what Mint is doing?
Yeah, I guess there's two things. I would encourage us to go and make really, really small
So
containers.
what Mint is
But
doing
what
is it's
Mint
trying
doing?
to do the thing where it determines, like when you run your application, you give it some way of actually validating that the application is doing its purpose, right? You have it scan the HTTP endpoints of that image. And then it's going to evaluate, based on that state, like what packages, what's on the file system that was used or loaded into memory while that was all happening. Now this means that there are some sharp edges, right? If you're not validating everything, you could run into trouble, et cetera. But
So yeah, it's going through a few rounds of static and dynamic analysis.
Yes.
One of the requirements that we've shown there is the flags, for example, to have extra interactions for the application endpoints. We had in the demo app for the ping and services endpoint. The gotcha there is that you need to know about the application something to add those interactions, and there it's a dependency. You need to know a bare minimum about the application, and you need to customize the flags and all of that in order to get full coverage.
yeah. All right, well, thank you very much.
All right, next up